everyone, and welcome to this week's live where we're going to be talking about fermentation. It is going to be a two-part series similar to the bone broth one, as there's really a lot to talk about on the subject of fermentation. So this week, we're just going to be talking about the history of fermentation and the different types that exist and the different types of bacteria that are inside fermented food. And then next week will be more instructions on how to actually ferment things. So to start with, so fermentation, like bone broth that we talked about last week, has a really long history. One could argue that actually fermentation is one of kind of the original foods that we, I mean, of course, fermentation is an actual kind of, I guess, preparation and preservation method. And like bone broth, it's been around for many, many years. So the first records of fermentation date back to ancient times. In China, koji making can be traced back to 300 BC, while in the Middle East, fermentation of milk started around 800 BC. So Egyptians made wine in around 400 BC, and you also used yeast to make leavened bread. And the earliest known fish fermentation was in Sweden around 700 BC. And the reason why fermentation was really popular was mainly as a method of preservation, because as you can imagine, fridges didn't exist basically. So if you don't have a fridge, there's no way to preserve food in the months when things don't grow as well. So imagine in the summer, there's really an abundance of vegetables and fruits and things that grow. And then in the winter, there's almost nothing. So this is why humans started to develop ways to preserve food in order to keep it for those leaner months and also for traveling. And the other thing is that once people transferred more into an agricultural state rather than a nomadic state, they would obviously have more access to storage and be able to store food in like a cellar or a different space, rather than being nomadic and constantly moving around. And maybe they would also have less access to a diversity of food compared to hunter-gatherers, so they would preserve food. They would develop methods of preservation. So fermentation is really part of every single food culture that exists around the world. And of course, you're probably familiar more with some than others. So for example, koji it's a type of yeast bacteria used in China to ferment things like rice and soy. And here is a photo of it. And fermenting soy, this is specific to soy, but any kind of food usually increases the nutritional value of it when you ferment it. So fermenting soy increases the nutritional value by enhancing certain components. So it increases essential amino acids, proteins, and vitamins. It can lead to an increase in protein, vitamins like vitamin K and vitamin B. It also reduces anti-nutrients such as tannin, phytates, and cyanides. This is really an important feature of fermentation because a lot of grains and a lot of beans have what are known as anti-nutrients. And what those anti-nutrients do is they bind to vitamins and minerals, and they inhibit the absorption of things in the digestive tract. So usually every single culture has a way of either of fermenting and aging and preserving beans and legumes in order to just increase the bioavailability and reduce the tannins, the phytates, the oxalates, any kind of nutrient inhibitor. So so fermentation of milk. So this in the Middle East in 800 BC was when the first kind of recorded milk fermentation happened. And one important thing to consider in the case of dairy fermentation is that in the case of lactose intolerance, fermenting dairy actually helps in order to digest it better. Because when we ferment dairy, lactose is broken down into glucose and galactose, which are more simple sugar molecules. And those molecules are much easier to digest than lactose. So one reason why, aside from just the preservation, one reason why milk was fermented was to increase to mitigate lactose intolerance, basically. And the probiotic feature of milk also helps us to digest, because when our guts are strong with a lot of probiotics, that helps to digest the lactose also. But one side note on lactose intolerance, um, just a brief history on lactose intolerance. So we all are able to digest lactose as babies, of course, because we drink our mother's milk. However, evolution would dictate that at some point during childhood, this function is no longer necessary and the lactose gene is essentially switched off. However, around 8,600 years ago, which is around the time we started dairy farming and also around the time of the agricultural revolution, many people developed a gene mutation, essentially, that allowed for lactose persistence. So as I'm sure you all know, when evolution happens, when we have some kind of mutation in the genes, that allow for some kind of fitness advantage. And then that advantage continues to be selected for because it gives us a species advantage, let's say. So basically 8,600 years ago, we had a genetic mutation that allowed us to digest dairy. And of course, this mutation allowed, this mutation became an advantage because, as I said, in winter, maybe there was not much food. And then during those months, people would be able to still extract the nutrients from their dairy animals, like sheep, cows, goats, and whatever. And of course, if you have access to more nutrients over winter, you're more likely to survive. You're more likely to be able to reproduce, and then that gene will kind of proliferate and continue in the species, which is what happened with lactose tolerance. So not only did this mutation explode in certain populations, but it also evolved independently across continents. However, each human-specific ability to digest lactose depends on whether one parent or both parent has the mutant chromosome that accounts for lactose persistence. So what can happen is that if one of your parents has the mutant gene and the other doesn't, you'll have a weaker ability to digest lactose than, say, someone whose both parents have this mutated gene. And this will explain things like, say, you might be able to digest cheese and yogurt, but you cannot drink a glass of milk. Whereas some people are so lactose intolerant that they can't have even cheese at all. Any trace amounts of lactose they really react to. So that explains a bit of that. And of course, there are many factors that can affect lactose intolerance. So for example, aside from the genetic mutation that allows for lactose persistence, of course, there's also if your gut health deteriorates and if you expose your gut to things like pesticides and heavy metals and unfiltered tap water and pharmaceutical drugs, then it's possible to damage the microbiome. And then what happens is your ability to digest lactose can be weakened. So there are many things really that factor into it. And a lot of people just think that, they're lactose intolerant when it's actually a lot more complex than that. And one thing, this is kind of a side note, but one thing that really annoys me is when I see these kind of advertisements, which are really popular these days, for nut milk, and for this one specifically for Oatly, which is an oat milk. And they kind of tout that that oat milk is for humans. And they're playing on this kind of vegan rhetoric that the only animals that should be drinking milk are baby animals and babies. And once we become adult, we shouldn't be drinking milk anymore, and it's not natural at all to drink milk. This is what the advertisement says, that oat milk is for humans and cow's milk is for baby cows. And this actually couldn't be further from the truth, because as we talked about, 8,600 years ago, we actually created a mutant gene pattern that then was continually selected for in the species, which is obviously a very human um, characteristic. And it's so human and so strong that our species continue to prioritize this mutant gene and select for it in the environment. So these kind of advertisements are just not scientific at all in that sense. Okay, so here are some ancient Egyptians. So grapes, 400 BC was the time when grape fermentation was around, or started in ancient Egypt. And here is a side note on wines. So as many of wine can be unhealthy, not just because of the alcohol, but also because of the way in which it's produced. Of course, pesticides, herbicides, sulfates, which are used to preserve the wine. And there's a huge kind of burgeoning trend in natural wines right now all around the world. But some people don't really know the difference between organic wine, biodynamic wine, and natural wine. So organic wine basically just means that it's made with organic grapes. So no herbicides, no pesticides, no artificial fertilizers. However, they're allowed to use yeast and enzymes and animal enzymes in order to stabilize and in order to kind of homogenize the fermentation process. So natural wine is also organic, but the wine is actually fermented with natural, spontaneous natural processes. And because of this, so this is the oldest method of making wine, but it's also the most difficult to do because, of course, if you're only using the natural fermentation, the spontaneous natural fermentation of the grapes, it's very hard to control, and some of them can ferment a lot faster and slower, and the same batch, one bottle can taste totally differently. So this is why it's much harder to kind of industrialize and produce on a larger scale. And the flavor can definitely vary. So biodynamic wine also avoids pesticides. They use compost as fertilizer. It's certified by a certain a governing body. It still can contain additives like sulfates, which help preserve it. But the most important thing with biodynamic wine is it's based on specific agricultural methods by a guy called Rudolf Steiner. And you might have heard of Steiner schools. It's a kind of alternative school system. And what this agricultural method does is kind of try to take into account the environment as a system. So, for example, what they'll do is they'll plant lentils next to the vine leaves, because lentils help infuse nitrate into the soil and help to fertilize in that way. So instead of adding extra things, what they'll do is try to grow different plants around the grapes in order to fertilize in that way. And it's more of a symbiosis and a system rather than just farming grapes. So that's really the differences between those. So fish farming, so Swedish fish fermentation, is dates back to around 7,000 BC. And what's interesting about the cold water fish is that they contain really high amounts of vitamin D. So things like salmon, mackerel, and sardines, they contain significant amounts of vitamin D. They also contain vitamins, of course, and fatty acids. And what's interesting about this is, as you can see from this graph, all of these cold water fish are very much present in the northern areas. So Scandinavia, Canada, all of the places that don't have that much sun. So as you can see from this graph, all of the northern regions, they have a lot less sun than the southern regions. And what this means is people need to get vitamin D in another way. And the environment will provide for that by these cold water fish, which are really high in vitamin D. So if you live in a region that doesn't have that much sunshine, then having these cold water fish is a good way to get more vitamin D. So this is just one really bizarre fermentation. This is probably the most strange fermented food. It's called kiviak, and it's eaten in, I believe it's Greenland. And basically what it is a type of fermented birds, and these birds are stuffed inside the carcass of a dead seal, and then they sew up the seal, and they bury it underground and let it ferment for several months, and then they eat it, and it's a delicacy during Christmas time. And this is, of course, a very strange fermentation. And there are a lot more easy and accessible ways to do fermentation, which we're going to talk about, and I'm sure many of you even know about and consume on a regular basis. Although that being said, as I said, because fermentation was part of every single food culture, and because it was used so much, because we didn't have fridges, we definitely eat a lot less fermented vegetables than we used to, and that is problematic because it just means we don't have the diversity of microbiome that we once did. And now I'm going to go on to just speak about all of the benefits of, having a diverse microbiome. So one is improved digestive health. So fermented foods restore the balance of bacteria, improve digestion, and alleviate symptoms of irritable bowel. And this is a picture of kombucha, which we will talk about how to make next week. So boosted immune system, the beneficial bacteria in fermented foods give your immune system a boost and reduce the risk of infections like the common cold. And in the context of long COVID, of course, this is important. The microbiome, we all know the gut immune system connection and how important gut health is in the context of immunity. So fermentation breaks down nutrients, making them easy to digest. So as I said, fermentation breaks down lactose into glucose and galactose, which is much easier to digest than the lactose itself. Increased availability of nutrients. Fermentation increases the health potential by producing more vitamins and minerals and making them more available. So again, and also it removes anti-nutrients such as phytic acid. And this is especially the case in things like legumes and grains. Improved mood and behavior. So certain strains of probiotic commonly found in fermented foods improve anxiety and depression and influence the production of cortisol. So again, the gut-brain connection, we're finding out more and more about this as time goes on, and how important gut health is when it comes to cognition and mental health. So support for heart health. So consuming fermented foods as part of a healthy diet appears to be associated with lower risk of heart disease, possibly due to the probiotics' ability to reduce blood pressure and also help lower bad cholesterol. Protects against toxins. So fermented foods enhance defenses and remove toxins from the body. And some of them actually bind to heavy metals and move them out the body. And some of them also reduce the absorption of pesticides and glyphosate in the gut. So this is really important if you're doing something like a heavy metal detox, to find out which probiotics can actually help to eliminate those toxins. So skin health. So fermented foods support skin health by influencing the gut biome, systemic inflammation levels, and insulin signaling. So they also modulate the gut-skin axis, which is a network of signaling molecules that links the GI tract with the skin. So I think skin microbiome is also something that's a science which is kind of emerging, and there's even research to show that your skin health overall, and when skin is not healthy and when skin ages, it actually has an impact on the whole body, on the whole system. And it kind of makes sense because skin is actually the largest organ of the body. So we need to kind of take care of it well by making sure that, and our skin has a microbiome, of course. So when we talk about microbiome, it's microbiome in every sense of the word. So here are a list of different bacteria that are found in the gut and what their function are, what each function is. So one thing that fermented food does that's different to, let's say, taking a probiotic capsule is that the diversity of bacteria present in a fermented food is much higher than in a probiotic. And this is because it's a wild ferment. The downside is that you don't know what kind of bacteria and in which quantity. So if you do something like a GI stool map, which I show on this slide, so here's a section from a GI stool map, then you can really see what bacteria are high and which are low. So in this specific one, you can see Clostridia is quite low. And in this sense, you can actually just target Clostridia and take a probiotic just with that. So it's not that that necessarily should mean that you should avoid fermented food. I think fermented food is something everyone should eat every day in order to get this diversity of bacteria. However, doing something like a GI stool map can help you really identify and isolate which bacteria are low, and then you can take a targeted supplement. And this often makes quite a big difference because I'm sure many of you recognize something like lactobacillus, which is in yogurt, maybe bifido, which is in many common probiotic strains. But some of these other bacteria, such as Akkermansia, are just less common, and they're not really present in even a broad spectrum probiotic. So if you're just taking, a broad spectrum probiotic and your issue is with another one of these bacteria, it won't necessarily help or do anything. And as we can see in each for this, let's see, so Clostridia, prominent and diverse group of bacteria in the large intestine. It produces short-chain fatty acids, including butyrate. It promotes healthy mucosal barrier, influences the immune balance, and protects against gastrointestinal pathogens. So low levels are associated with inflammatory and autoimmune conditions, and high levels are associated with metabolic dysfunction. So in this case, this person had low levels, so that's associated with inflammatory and autoimmune conditions. So this is something good to know and pay attention to, because then you can supplement in a more targeted way. And as you can see, each bacteria has a slightly different function, and if it's high or low, it will mean something slightly different. Lactobacillus, let's see this one. This is a really common one that's present in a lot of that's present in yogurt and in a lot of probiotics. So it's a gram-positive genus of lactate-producing bacteria. Many strains used as probiotics, so high levels may result from reduced digestive capacity or excessive intake of carbohydrates, and low levels might be due to low carbohydrate intake or high salt intake, and may also indicate reduced mucosal health. So just lastly, on the case of bacteria in the gut, it's important to remember that there are many steps to optimizing our gut health, and it's not just about probiotics. So many people say, oh, I have all these issues with my gut. Will probiotics cure them? And the answer is it might, if the problem is that specific probiotic. But in general, when it comes to gut health, we focus on these, what we call the 5 R's. And the 5 R's are remove, replace, reinoculate, repair, and rebalance. So removing is, of course, getting rid of microbes, virus, fungus, parasites. And again, this will show, in the GI stool map, if you have a parasite, if you have candida, it won't necessarily help to just eat fermented food or take probiotics. You might need to take something like berberine, garlic oil, microemulsified oregano to really get rid of these pathogens that shouldn't be in the gut. And then you need to replace. So in the cases of maldigestion or malabsorption, it may be necessary to restore the proper digestion by supplementing with enzymes. So sometimes we need to replace, often the reason why we have kind of a pathogenic attack in the GI stool map is because we have low stomach acid, for example. And since the stomach is extremely acidic environment, it shouldn't really allow these pathogens to accumulate there. So if you have that issue, it might be the case that your acid is low, and supplementing something like betaine HCl, apple cider vinegar, herbal bitters, ox bile, whatever it is that's missing and that had allowed for the infiltration of pathogens, it's important to kind of replace that, whether it's enzymes, whether it's acid. And things like apple cider vinegar also help with that, because apple cider vinegar generally just stimulates enzymes to be produced. So reinoculation, this is the next point, and this is where the probiotics come in. So recolonizing with healthy, beneficial bacteria to reestablish the balance. So lactobacillus, bifido, all of these different ones, but also prebiotics. So fiber, inulin, pectin, anything, with the things like the prebiotic vegetables like Jerusalem artichoke, asparagus, all of these things are also really important, because the prebiotics actually feed the bacteria, especially in the large intestine. So you want to repopulate, but you also want to feed the bacteria that you're repopulating with to keep them alive. The fourth R is repair. So restore the integrity of the gut mucosa by giving support to mucosal cells as well as the immune system. And these are things like colostrum and immunoglobulins. And then intestinal barrier repair are things like glutamine, aloe vera, licorice. I never know how to say this word, deglycyrinizated licorice. This is a really good one for just repairing the mucosal layer, along with things like marshmallow root, slippery elm, okra, NAC, glucosamine, quercetin. I think I mentioned slippery elm. Vitamin A, essential fatty acids, carnosine. So these are all the things that actually help to repair. And then rebalance. So this is the idea of looking at the more macro factors that affect our gut health. So, of course, stress, diet, exercise, sleep, all of these things will affect gut health. If we eat in a sympathetic state rather than a parasympathetic state, if we're sleeping at 3 a.m. every day, that will affect our microbiome, because our microbiome circadian rhythm will not be necessarily synced with the way we're actually behaving in the world. And then this disconnect will create imbalances in the microbiome. So we need to understand from a whole body level what actually caused the gut to become disrupted in the first place, and then try to fix those diet and lifestyle changes. Because of course we can do all of these things: remove, replace, reinoculate, and repair. But if your lifestyle and your diet and your stress management stay the same, then you'll just cycle back around into the same problems again. So this is really kind of from a systemic level. And this is also to understand at what point the fermented food and the probiotics, how they fit into this whole picture, and how they fit in is in this reinoculate phase. So that's that. Let me see if there are any questions. Okay, is kimchi a good fermented gut health food? Um, so yeah, kimchi is great. Kimchi, there's kimchi is, for anyone who doesn't know, is a fermented cabbage. Usually they use Napa cabbage. Sometimes it has carrots and other vegetables, but it centers around cabbage, and it also contains gochujang, which is a Korean chili flake, and fish sauce. So it's basically a Korean version of sauerkraut, which is the German fermented cabbage. It's much more flavorsome and strong in flavor, and cabbage itself has many, health benefits. And then if you add the fermented aspect to it, it's a good one for gut health, and it's also really flavorsome and can be added to many different dishes. So what's the difference between food fermenting and rotting? So I think so next week when we talk about how to do fermented food, I'm going to talk a lot about that because this is really a confusing thing, I think, because often fermented food actually smells quite bad and quite strong. And if you can imagine this kiviak dish that I showed earlier, which is the birds stuffed inside a seal carcass and fermenting for 3 months underground. This must, I mean, I've never seen it, but this must smell completely horrible. So how do you know when it's just rotten? And in the case of vegetables and kombucha, which we're going to talk about how to do next week, it's much easier to tell because you'll see things like mold growing on the surface. And this is why there are very specific techniques to use to do fermentation, and that will avoid the mold growing. Um, and yeah, so I'm going to speak more about that next week. But once you get a bit of experience on what to look out for, you'll know the difference between when something is rotting and fermenting, and you'll also learn by the smell because the smell of something rotting and fermenting are two quite different things. Although at first it's always a bit intimidating because fermented food doesn't smell great, so it can smell rotten, but there really is a distinct difference in the smell. So would fermenting vegetables with vinegar be as healthy as fermenting with brine? So yeah, this is also something I'm going to cover next week because a lot of people think that pickling, what's called, well, there's many names for this, but one type of pickling that people do is what's called quick pickling. And what they do is they heat up vinegar sometimes with some aromatics and a bit of sugar, and then they pour that vinegar, that hot vinegar, onto, let's say, carrots, and then it preserves them, and you can add them to salad and different things, and they taste really good because they're really vinegary and it preserves them for many months. However, the difference is that this is a process of sterilization. It's not a process of fermentation. So if you imagine heating something like vinegar to a high heat, you're killing all of the bacteria, and then you're pouring that onto the vegetable, thus also killing the bacteria there. And the reason why it keeps for a long time is because it's sterilized. And that is kind of the opposite of fermentation. Because with fermentation, what you're doing is you're cultivating bacteria, and those bacteria then produce lactic acid. And that acidic acid is actually what preserves the vegetable. And in that case, then you have all of the probiotics because the fermentation creates lactic acid activity and lactic acid bacteria. And then the acid is what preserves. And then that's how we have this amazingly rich probiotic food. And you can create a saltwater brine that's then poured onto vegetables at room temperature, and then that will be probiotic in itself because it's fermenting over. You usually ferment it for around less than a week outside the fridge, and then you put it in the fridge. And this kind of brine, saltwater brine, will be full of beneficial bacteria. However, the vinegar brine, the hot water vinegar brine that used for quick pickles, that has no probiotic quality at all. So that is the difference. In the health program, do you also give recipes? Yeah, so we do. We share a lot of recipes. depending on, usually every week we talk about, at the end of every week we have a call, and often in that call we talk about different recipes and things that you can try in regards to whatever the topic is of the week. So yeah, recipes are definitely something that we share. And if anyone is interested in speaking more about the program, you can also book a discovery call with me at Michelle@mygotodoc. So Michelle@mygotodoc.com. So anyone who's interested can write to me there and organize to book a free discovery call, and we can speak in more detail one-on-one about what's in the program and if it can be a good fit for you. So next question is, do fermented vegetables cure acid reflux? Yeah, okay. So actually, one one kind of misconception about acid reflux that people have is that it's caused by too much acid. And a lot of times it's actually caused by too little acid. It's quite the opposite. And this is because when we don't produce enough hydrochloric acid, our body is really struggling to digest things because food comes in, pathogens come in, the stomach, it doesn't have the proper enzymes, the proper acid to digest well. And then it's churning around, and any kind of acid that's there is coming up through the esophagus, and then that's what burns. So if that's the case with you, and your heartburn is caused by low stomach acid, then having fermented food can actually really help, because it increases the acidity of the stomach, and then increasing the acidity should help you to be able to digest more and also feed the microbiome, which in turn will also, help the overall health of the gut. So it would be worth a try, definitely, if you have heartburn, to try a small amount of fermented food and see if it makes a difference. And one good thing to try is actually the unpasteurized apple cider vinegar. So there's a brand, I think it's called Bragg's, and it usually says with the mother, unpasteurized and with the mother. And what that means is that the apple cider vinegar has a lot of beneficial bacteria, and it has this kind of, you'll see a kind of cloudy, it looks like what's inside kombucha. It's like a cloudy kind of jellyfish type of thing, and that's the probiotics that are forming in the apple cider vinegar itself. And if you take a little bit of apple cider vinegar and some water before a meal, it can definitely help to acidify the stomach, to trigger the enzymes, and also to avoid heartburn. So that's something good to try. Okay, I think that's it for questions. Thank you everyone for listening. And yeah, I'm looking forward to sharing the part 2, which is going to be on how to actually make fermented vegetables, lacto ferments, and we're also going to do saltwater brine, and I'm also going to cover kombucha. So that will be next week. Thank you very much. Thanks for listening, and see you next week. Bye-bye.